Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me in my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the Telangana State Entrance Exam 2024, that is TG Set 2024. In this video, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the concept of the trace and the results related to the trace of the matrix. And this question is placed as the serial number 66 in this question paper. This question is suitable for all these examinations. Right. The given problem is for any n by n matrix A, let TR bracket A denote the trace of the matrix A. Then which of the following statements is false? We have to find out if a false statement. That means out of these four options, three of them are true and one is false, and we have to identify that option. We are given four options. Option 1, if AB are n by n matrices, then trace of AB is equal to trace of BA. Option 2, if A is equal to A square, then the rank of A is trace of A. Option 3, if ABC are n by n matrices, then trace of ABC is equal to trace of BCA is equal to trace of CAB. Option 4, there exists two n by n matrices AB such that AB minus BA is equal to identity. Here n greater than or equal to 2. Right. We have to find out a statement which is false out of these four. And if you look at these four options, you might have studied in your BSc first year or even in plus 2 level. This option 4 is not true. And the remaining are all true, and it is false. The fourth one is false. So the answer to this question is option 4. Right. But our students ask, how they are true, how this statement is false. Right. Let's now discuss the solution of the problem in detail. We take up option 1. If AB are n by n matrices, then the trace of AB is equal to trace of BA. It's a well-known fundamental property of the trace of the matrices. Right. So I will give you a very quick proof for that. Let A be Aij n by n. Let B be Bij n by n. Let AB is equal to capital X is equal to Xij n by n. And BA is equal to Y, where Yij n by n, where Xij is sigma, K is equal to 1 to n, Aik into Bkj. And what is the trace? Trace of capital X is the sum of the diagonal entries of X, that is sigma I is equal to 1 to n Xii. So sigma I is equal to 1 to n. For Xii, you write sigma K is equal to 1 to n Aik into Bki. So this is what we have written. In a similar fashion, you will also write for trace of Y, and you will find sigma I is equal to 1 to n, sigma K is equal to 1 to n, Bik Aki. Now, can you find out these are equal? Now, trace of BA is equal to trace of Y. What is trace of Y? Sigma I is equal to 1 to n, sigma K is equal to 1 to n, Bik into Aki. This is written as sigma is equal to 1 to n, sigma k is equal to 1 to n, aki into bik. Use commutativity. Agreed? Agreed. Now this is equal to sigma k is equal to 1 to n, sigma I is equal to 1 to n, akj bik. Since the summations are finite, you can swap them. Or if you are not interested in this argument, what you do is replace I by k, k by I and I by k. Swap them. The indices, swap them. And this is precisely equal to trace of x, that is trace of AB. Thus, we have proved trace of AB is equal to trace of BA for all n by n matrices. Thus, option 1 is true. Right. We move on to the next option, option 2. If A is equal to A square, then the rank of A is equal to the trace of A. Right. Now, A is equal to A square implies A is an idempotent matrix of order n. We know that the only possible eigenvalues of an idempotent matrix are 0 and 1. Suppose that A has k eigenvalues each equal to 1 and the remaining n minus k eigenvalues each equal to 0. Now A square is equal to A implies x square minus x. That means A square minus capital A square minus capital A is equal to 0. That means x square minus x is an annihilating polynomial of A. Then if you consider its minimal polynomial, that minimal polynomial divides every annihilating polynomial, therefore it divides x square minus x. This implies the minimal polynomial ma of x divides x into x minus 1. Further, x into x minus 1 has distinct roots. Then recall a property of the diagonalization. This implies A is diagonalizable. This implies A is diagonalizable. A is diagonalizable means A is similar to a diagonal matrix, let us say capital D, where D has eigenvalues of A on its main diagonal. Now, trace of A will be the number of ones on the diagonal of D. That is k. And the rank of A is the number of non-zero rows of D. There will be k non-zero rows. That's equal to k. Thus, the trace or rank of A is same as trace of A when A is an idempotent matrix. Thus, the option 2 is true. Right. We move on to option 3. If ABC are n by n matrices, then trace of ABC is equal to trace of BCA is equal to trace of CAB. And to prove this result, we use the first fundamental property of the trace, that is trace of AB is equal to trace of BA for all n by n matrices A and B. We apply it here. Now, trace of ABC is equal to trace of A into, in brackets, BC. Right. And use now, you can trace of xy is equal to trace of yx. This will be equal to trace of BC in bracket A. That is same as trace of BCA. Agreed. Now, trace of ABC is equal to trace of, in brackets, AB and multiplied by C. And I use trace of xy is equal to trace of yx, and that's equal to trace of C into, in brackets, AB. That is precisely trace of CAB. Thus, they are all equal. They are all equal. So, thus we have proved the result. Hence, option 3 is true. So far, all the 3 options are true. Therefore, by elimination, option 4 is a false statement, will be a false statement, and the answer to this question will be option 4. Right. Option 4. There exists 2 n by n matrices AB such that AB minus BA is equal to I. here n greater than or equal to 2. Given n greater than or equal to 2, assume that option 4 is true. That means there are two n by n matrices, or there exist two n by n matrices AB such that AB minus BA is equal to In. Take the traces on both sides. Trace of AB minus BA is equal to trace of In. Now, this will imply trace of AB minus trace of BA is equal to trace of In. Trace is a linear transformation. So the trace of, we know trace of AB is equal to trace of BA for all n by n matrices A and B. So this will be equal to 0 is equal to trace of In is n. So we get 0 is equal to n. This is a contradiction to the fact n is greater than or equal to 2. Therefore, this contradiction will tell us our assumption, what we have made, that option 4 is true, is false. So therefore, that is, there does not exist two n by n matrices A and B such that AB minus BA is equal to In when n greater than or equal to 2. Thus, option 4 is false. And we are asked to find out that statement which is false. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the problem from the section linear algebra, which is related to the concept of the trace of the matrix and the results related to the trace. And it's a very simple, straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.